Lesson 2.3. Our objective is to solve two-step equations. Rules for solving equations. Number 1. Your goal is to isolate the variable on one side of the equal sign. Number 2. Always perform the same operations to both sides of the equal sign. Number 3. To undo an operation, perform its inverse operations to both sides. Number 4. When solving two-step equations, apply the inverse operations in the reverse order of the order of operations. Example 1. Solve the equation and check your solution. For this example, we have 6 problems. We'll work 3 together and you'll try 3 on your own. So let's go ahead and get started. If you look at the problems in this example, you probably noticed that they look like a combination of lessons 2.1 and 2.2 put together. For instance, let's take a look at the first one. I have 2x plus 5 equals 15. If I were to take away this coefficient, the 2, I'm left with x plus 5 equals 15. Problems like this are the types of problems we solved in lesson 2.1. Now, if I were to take away the plus 5, then I'm left with 2x is equal to 15. These are the types of problems we solved in lesson These are the types of problems we solved in lesson 2.2, example 1. And this problem is really just a combination of them both. So these are the types of problems that we're going to learn how to solve today. They're fairly simple. So let's look at this first one. I have 2x plus 5 equals 15. My goal is always the same. It's still the same. My goal is to isolate the variable. So that means I need to get this x by itself. So I want to get rid of the plus 5 and I want to get rid of the 2. I'm going to use the same properties as I did in the 2 previous lessons, but I'm going to start off by drawing the line down. Going to do that. Going to divide my equation into 2 parts, the left side and the right side. And I'm going to use the same properties. I'm going to focus on this plus 5 first. And I'm going to do the opposite, the inverse of plus 5. In order to get rid of that, I need to do a minus 5. So I need to subtract 5 from both sides. Then I'll bring down what I have left. Bring down my 2x. 5 minus 5 is 0. That cancels out. Bring down my equal sign. And 15 minus 5 is 10. Now from this point, I know how to get rid of this coefficient 2. This is 2 times x. So I'll do the opposite of multiplying. I'll divide. I'll divide both sides by 2. 2 divided by 2 is 1. It cancels out. I'll bring down my x. Bring down my equal sign. And 10 divided by 2 is 5. So the solution to this equation is x equals 5. Now I do want to check. I want to check my answer. So the original equation was 2x plus 5 equals 15. Okay? Now, if 5 is the answer, the correct answer, if I replace this x with 5 and work it out, I should get 15 if it's the correct answer. So let's see. 2 times 5 is 10. Bring down my plus 5. Huh. Hmm. And then 10 plus 5 is indeed 15. So this checks out. So that lets me know that I have the correct answer. Let's look at the next one. This time I have 6x minus 5 equals 25. Start off the same way. I'm going to divide my equation into 2 separate parts. Remember, my goal is to isolate the variable, so that means I need to get rid of this 6 and I need to get rid of the 5. So once again, I focus on the minus 5. I'm going to always do, in a problem like this, I'm always going to do the addition subtraction part first. So since this says minus 5, I want to do the opposite and plus 5. Let's bring down what we have left. Bring down the 6x. Negative 5 plus 5 is 0. Bring down the equal sign. And 25 plus 5 is 30. Now I'm left with 6 times x equals 30. Now I'm down to the multiplication part. The inverse of multiplying is division. So that means I want to divide by 6. I'm trying to get rid of the 6, so that's what I need to divide by. 6's cancel out. Bring down the x. 30 divided by 6 is 5. So I'm saying that the solution to this equation is 5. Want to check my answer to make sure that it's correct. If I replace x with a 5 in the original equation, it should equal to 25 if 5 is the correct answer. So let's check and see. So this becomes 6 times 5 minus 5. 6 times 5 is 30 minus 5, and 30 minus 5 is 25. So it checks out. When I made my substitution, I got 25, so that lets me know, hey, you got the right answer. Let's go ahead and try one more together. Let me scroll down just a smidge, and we're going to try this next problem. It's 9x minus 5 equals a negative 13. Starting off the exact same way. Draw my line down to separate it into two parts, my left side and my right side. I have 9 times x minus 5. I need to get rid of the minus 5, so I do the inverse and plus 5. Bring down what I have left. So this gives me 9x equals negative 13 plus 5 is negative 8. Divide both sides by 9. Need to get rid of that coefficient. 9's cancel out. Bring down what I have left. Let me extend my line just a little bit. Bring down what I have left. X equals negative 8 over 9. And if your answer comes out to be a fraction, don't worry about it. Don't be afraid of it. Just check your answer. If it checks out, you're good to go. So now let's check our answer over here. So now, if negative 8 over 9 is the correct solution, then I should get 13 when I make that substitution. I'm going to plug it back in where the x value is. Okay? So this becomes 9 times a negative 8 over 9 minus 5 should equal negative 13 if it's the correct answer. Well, I see I can simplify before I get started. So this leaves me with negative 8 minus 5, and negative 8 minus 5 does equal a negative 13. So I know I have the right answer. So that means that the solution to this equation is x equals a negative 8 over 9. Now I want you to pause the video, work the remaining 3 problems on your own, then restart the video so that you can check your answers. Okay, if you've restarted the video, that means you're ready to check your answers. So let's go ahead and get started. The next problem that we have is 3x plus 5 equals 26. I want to start off by drawing my line separating my equation into 2 separate parts. I know I need to get rid of the 3 and I know I need to get rid of the 5, so I'll start with the 5. I'm going to minus 5 from both sides. Bring down what I have left. 3x is equal to 26 minus 5 gives me 21. Now I have 3 times x equals 21. The inverse of multiplying is dividing, so I'll divide both sides by 3. 3's cancel out. It gives me x equals 7. 21 divided by 3 is 7. So my solution is x equals 7. Now I'll go over here and check my solution. The original equation was 3x plus 5 equals 26. If I substitute the 7 back in for the x, that gives me 3 times 7 plus 5 should equal 26 if it's the correct answer. 3 times 5 is, 3 times 7 is 21 plus 5. 21 plus 5 gives me 26. So that lets me know that I had the correct answer. X is 7. Okay. Check the last two. The next one I have 7x minus 6 equals 72. Start off the exact same way, draw my line. Now I have a minus 6, so I need to plus 6. This has to be the first thing that I do. Bring down what I have left, 7x. 6's cancel out. Divide both sides. No, excuse me. 72 minus 6 gives me, 72 plus 6 gives me 78. Now I'll divide both sides by 7. So that gives me x equals 78 over 7. Now, me personally, I don't mind you leaving an answer as an improper fraction. Your teacher may want you to change it to a mixed number. If so, you can change that to 11 and 1/7. And that's my final answer. Okay? And let's check your last one. It's 12x plus 4 equals 52. Draw my little line down. Start off the same way. I have 12x plus 4 equals 52. So that means I need to minus 4 first. Bring down what I have left. Cancels out. 52 minus 4 gives me 48. Then divide by that 12. 12's cancel out. I'm left with x equals 48 divided by 12 is 4. So my solution is 4. So I want to check my solution. Original equation was 12x plus 4 equals 52. I'll replace the x with a 4 because that's what I'm saying my solution is. And then 12 times 4 is 48 plus 4. 48 plus 4 is 52. So it checks out, so that lets me know that I have the correct answer. I do see that I forgot to check my solution on the previous problem, so I'll go back and do so. So I need to check this one. The original equation was 7x minus 6 equals 72. So I'm going to replace the x with 78 over 7 because that's what I'm saying that the solution is. Going to reduce this before I get started. 7's cancel out, so that leaves me with 78 minus 6. 78 minus 6 is indeed 72. So since that checked out, I know my solution is correct. Example 2. Solve the equation and check your solution. If you look at the problems that are in example 2, you've probably noticed they are really just a combination of the types of problems that you learn how to solve in lesson 2.1 and 2.2. For example, if I look at this first problem, I have x over 3 plus 5 equals a negative 8. If I were to cover up or take away the denominator and I was left with x plus 5 equals a negative 8, those are the types of problems that you solved in lesson 2.1. Now, if I were to cover up, take away the plus 5, then we're left with x over 3 equals a negative 8. Those are the types of problems that you learn how to solve in lesson 2.2, example 2. Well, you know how to solve them individually. Today, for this lesson, we just have them put together and you're going to learn how to solve it. It's a fairly simple process, so let's go ahead and get started. My goal is always the same, to isolate that variable x. So I need to get the x by itself. And I'm going to start off the exact same way as I did with previous problems. I'm going to draw my line and divide my equation into two separate sections. I have a left side and the right side. I also have to remember that if I do something to the left, I also have to do it to the right in order to keep it equal. Well, I'm going to get rid of this plus 5 first. And I know how to get rid of that. I learned how to do that in lesson 2.1. I have to do the opposite. The opposite of plus 5 is to minus 5. So I'll minus 5 from both sides of my equal sign. I'll bring down what I have left. That leaves me with x over 3 equals negative 8 minus 5 gives me negative 13. Now from this point I'm left with x over 3 equals a negative 13. I learned how to get rid of the 3 in the denominator in lesson 2.2. So I know I need to multiply both sides by 3. I'm going to multiply both sides what's in my denominator, okay? Cancels out, the 3's cancel out. I bring down what I have left. I have x equals, and negative 13 times 3 gives me a negative 39. So for my solution, I have x equals a negative 39. Now that's what I say the solution is, but I need to check it just to verify that I have the correct answer. My original equation was x over 3 plus 5 equals negative 8. I'm going to replace this x with what I say the solution is, negative 39. So it becomes negative 39 over 3 plus 5 should equal negative 8. Well, negative 39 divided by 3, that gives me negative 13. Then I bring down the plus 5. Negative 13 plus 5 does give me negative 8. Well, since that checked out, it lets me know that I do have the correct answer. The solution to the equation is x equals a negative 39. Let's look at the next one. Let's try it together. Start off the same way. Draw your line down. I have x over 6 plus 9 equals 14. I know I need to get rid of the plus 9 first. So I want to do the opposite. The opposite of plus 9 would be to minus 9, subtract 9 from both sides. Going to bring down what I have left. X over 6. Bring down your equal sign. And 14 minus 9 will give you 5. Now I'm left with x over 6 equals 5. This is x divided by 6 equals 5. So since this is now a division problem, I want to do the opposite and I want to multiply. I'll multiply by the denominator. Whatever's in my denominator, that's what I'm multiplying by because that's what I'm trying to get rid of. So the 6's cancel out. Bring down what I have left. And 5 times 6 gives me 30. I want to check my solution because I could have made a mistake somewhere and I just need to check it to make sure that I've done it correctly. The original problem was x over 6 plus 9 equals 14. I'll replace that x with 30. And when I work this out, if it equals 14, I know I have the correct answer. So 30 divided by 6 gives me 5. Bring down my plus 9. 5 plus 9 is indeed 14. So that checks out. So that lets me know that I have the correct answer. Now you may, if you feel comfortable, you may want to pause the video and work this last problem by yourself and then restart the video. If not, I'm going to go ahead and continue to work the problems. The next one that I have is x divided by 7 minus 2 equals negative 9. Same thing. Do the same thing over and over and over. Draw my little line. I know I have to focus on this minus 2. That's what I need to get rid of. So I'm going to do the inverse, the opposite of minus 2 plus 2. Add 2 to both sides. That's how we're going to get rid of that 2. Bring down what I have left. X over 7. Negative 2 plus 2 is 0. It canceled itself out. Bring down my equal sign. And negative 9 plus 2 gives me negative 7. Now I need to get rid of this 7 in the denominator. You do that by multiplying both sides by 7. 7's cancel out. Bring down my x. That will give me negative 7 times a positive 7 is a negative 49. So I have my solution equals a negative 49. Once again, you always want to check. You may have made a mistake somewhere. You never know. So let's check. The original equation was x over 7 minus 2 equals a negative 9. I'll replace this x with negative 49. So that becomes negative 49 over 7 minus 2 equals negative 9. So now negative 49 divided by 7 is just 7. Negative 7, excuse me. Bring down minus 2. And negative 7 minus 2 is negative 9. So that checked out. So that lets me know that my correct answer is indeed x equals negative 49. Okay, now let's go on to example 3. Example 3, solve the equation and check your solution. If you look at the problems that we have in example 3, just like the previous two examples, they're actually just a combination of problems that we learned how to solve in the last two lessons. For example, if I were to take away that coefficient 3/4 and I'm left with x minus 3 equals 12, those are the types of problems that you learn how to solve in lesson 2.1. And if I were to take away this minus 3 and all I have is 3/4 x equals 12, we did those problems lesson 2.2 example 3. So now we just have a combination of the two. We know how to solve them separately. Now we're going to do them together when they're together, okay? Start off the same way. I'll draw myself a line down, creating two separate sections. I know whatever I do to the left, I must do the same thing to the right. I know that my goal is to isolate the variable, so I need to get this x by itself, meaning that I have to get rid of the 3/4 and I need to get rid of that minus 3. I'm going to start off the same way as I did other equations. I concentrate on the minus 3 and I want to do the opposite, the inverse. The opposite of minus 3 is to add 3. So I'm going to plus 3 to both sides of my equal sign. I'm going to bring down what I have left. That gives me 3/4 x. Negative 3 plus 3 is 0. Bring down my equal sign. And then 12 plus 3, it's 15. Now I know how to get rid of this coefficient when it's a fraction. I want to multiply by the reciprocal. And the reciprocal of 3 over 4 is simply 4 over 3. Have to do that to both sides of my equal sign. On the left, I know it cancels out. So I'll just bring down my bring down my x, bring down my equal sign, and 15 times 4/3. I'm going to reduce before I get started. I know that 3 will go into 15 5 times, and 3 will go into 3 1 time. So now I can multiply 5 times 4, which is 20, and I keep that same denominator, which is 1, so I'm left with x is equal to 20. That's my solution. So now I want to check my solution, and I'm checking it by replacing it into the original equation to see if the left side equals the right side. My original equation was 3/4 x minus 3 equals 12. So now I'm going to replace that x with 20. Then rewrite minus 3. Now if this is the correct answer, it should equal 12. Let me go ahead and write that. Should equal 12. So I multiply 3/4 times 20. I know that 4 will go into 20 5 times. 4 will go into 4 1 time. So now I can multiply the whole number in the numerator, which gives me 15. Keep the original denominator, which is 1, and then bring down my minus 3. So this gives me 15 minus 3, which is indeed 12. Well, it came out to be 12, so that lets me know that what I wrote as the solution, x equals 12, was the correct answer. Let's go ahead and try the next one. Now here I have 3/5 x minus 6 is equal to 3. Start off drawing the little line. I want to do the opposite of minus 6. Start off the same way each and every time. I want to do the get rid of this minus 6. I do the inverse. The opposite of minus 6 is to add 6. So I want to plus 6 on both sides. Bring down what I have left. It's going to be 3/5 x. 6's cancel out. Bring down my equal sign. And then 3 plus 6 is 9. Okay? Get rid of this get rid of the fraction. I'm going to multiply by the reciprocal. So the reciprocal of 3 over 5 is 5 over 3. Do to the left as well as the right side. Cancels out here. Left with x on the left. Bring down the equal sign. Once again, I'm going to reduce before I get started. And I know that 3 will go into 9 3 times. So this becomes 3. This becomes 1. 3 times 5 is 15. And I keep the original denominator. So that means that my answer is just x equals 15. Once again, I want to check my solution. The original equation was 3/5 x minus 6 equals 3. I replace the x with 15 because that's what I say the solution should be. Now if this equals 3, then I know I have the right answer. Once again, this is a 5. Let me fix this a little bit so it'll actually look like 5. I know that 5 will go into 15 3 times. So this becomes a 3. And 5 will go into 5 1 time. So it becomes a 1. Now just multiply my numerators. My numerator times that whole number is 9. Keep the original denominator, which is just 1, and bring down my minus 6. 9 over 1 is just 9. So 9 minus 6 gives me 3. Well, that checks out. So I know that, hey, I have the correct answer. 15 was the right answer. Now let's look at this last one together. This time I have 1/8 x plus 4 equals 6. Same old, same thing. Divide your equation into two parts. This time I have plus 4. Opposite of plus 4 is to minus 4. So I want to say minus 4 to both sides. Bring down what I have left. At 1/8 x equals, and then 6 minus 4 is just 2. The reciprocal of 1 over 8 is just 8 over 1. So I'll multiply both sides by 8 over 1, which is actually just 8. Okay, side cancels out. Bring down my x. Now 2 times 8 is 16. So my solution is just x equals 16. Once again, as always, I'm going to go over here and check my solution. The original equation was 1 over 8x plus 4 equals 6. Now I have that the solution is 16, so I'll replace that x with 16. Then bring down my plus 4. Now if 16 is the correct answer, I should get 6. Once again, I start off by reducing before I get started. 8 will go into 16 twice. 8 will go into 8 one time. 2 times 1 is 2. 2 over 1 is the same as 2. Then bring down my plus 4. And then 2 plus 4 is indeed 6. So that lets me know, hey, My answer was correct. The solution to the equation was x equals 16.